All right, welcome everybody. Today we're going to be talking about balancing chemical equations. This is sort of our continuation of learning about chemical equations in general and the last main concept in Unit 3. All right, so let's get started. So, balancing equations. First of all, what is balancing an equation and why do we need to do it? So, balancing an equation is looking at an equation like the one we have down here and making it so that all the number of atoms on each side is the same and the number of each type of atom is the same as well. Okay, so in this case we have carbon, hydrogen, and oxygen on both sides, and if we count them up, we've got 1 carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side. Okay, and that number only works out because we have these coefficients out front it's called balancing the equation. Okay, so the reason we have to do this is chemical equations, we use them to predict two things. One is what the products are going to be if we react to specific things. So basically, if I react methane and oxygen, I know from sort of the experience of past chemists, but also from theoretical chemistry, that this is going to make carbon dioxide and water. Okay, but we also use it to know how much product of each product is going to be made if we start with a certain amount of reactants. Okay, we're not going to get into predicting that number, but know that predictions about how much of each reactant we need and how much of each product we're going to get only work if the equation is balanced, aka it follows the law of conservation of mass, which states that like I said before, the number of atoms in the reactants and the products needs to be the same for each type of atom. Okay, so this is why balancing is important. Okay, so how do we do it? Well, first, before we even do any of the math to attempt to balance it, we need to write out what we have already. Okay, so first of all, you have your equation up top. You should draw a line down the middle underneath the arrow to separate the two sides. Then you should identify the different elements on each side. Okay, so in this case we have carbon, hydrogen, and oxygen, and carbon, hydrogen, and oxygen over here. You're never going to have a different set of atoms on both sides, right? Like, you're never going to have nitrogen over here but not nitrogen over there. Okay, the lists are always going to be the same. Okay, and then step number 3 is you count the number of each type of atom on each side and list the amounts. Okay, so up here we've got 3 carbons, so that's 3 down here, 8 hydrogens down here, and 2 oxygens, which we put down there. And then up here we have our 1 carbon again. Well, we have carbon again, and there's only 1. We have 2 hydrogens down here in the water. And then we have 1 oxygen from the water, and then 2 more from the carbon dioxide. So we have 3 in total. Okay, remember to put the total number down below before you start. All right, and then with these numbers down here, we should basically try to make our numbers into make it so all of the numbers we have listed are the same. Okay, and so it takes a little bit of guess and check work, but we do have a recommended order that you follow, which is that it's called MENO is the mnemonic device, but basically start with metals, then do non-metals, except O and H, then do oxygens, and then do hydrogens. Okay, so this sort of sounds complicated, and it's kind of hard to understand just by hearing about it conceptually. So let's just do some examples. All right, and we're going to do plenty more examples in class, don't you worry. All right, so here we have an unbalanced equation. So this is iron and oxygen combining to form iron 3 oxide. Okay, so our first step, if you remember, is draw a line down the middle, and then we list our elements. We have iron and oxygen, and then iron and oxygen, and then we count them up. So on the left side, on the reactants, we only have 1 iron, and we have 2 oxygens, and then in the products, we have 2 iron and 3 oxygen. Okay? So, remember our order that we balance them in is meno. So, we start here. We start with the metals. Do we have any metals? Yes, we have iron. So, we need to make these two numbers equal. Best way to do that is start with the smallest one and add a coefficient so that they are the same. Okay, so the smallest one is over here on the left, it's 1. So we write a 2 out front of the irons, and the number of irons changes to 2. Okay, now the irons are balanced. Let's try to do next, which is non-metals, except for oxygen and hydrogen. Well, there are no non-metals other than oxygen, so we're done with N. Now we're on to O, which is oxygen, and let's balance these. Okay, this one's a bit harder, right? Because you can only put whole numbers in front of as coefficients. You can't like put a 1.5 out front. So how can we make these two numbers equal? Well, we have 3 over here and 2 over here. The sort of lowest common factor of those two is going to be 6. So if we put a 2 out front here and a 3 out front here, then this 2 becomes 6 and this 3 becomes 6. But now this 2 that we did has now changed the number of irons to be 4, oops, instead of 2. So we need to go back here and change that number to 4. And then finally we've got 4 irons here, 4 irons here, 6 oxygens here, and 6 oxygens here. And we are fully balanced. Okay, so as you can see, it takes a little bit of guessing and checking, but if you just make sure that you stay consistent and you note how every single number changes every time, you will get there eventually. And remember to follow meno. Alright? Okay, so example 2. Here's a double replacement reaction. We've got iron sulfate plus potassium hydroxide yielding potassium sulfate and iron 3 hydroxide. Okay, so let's draw our line down the middle and list our elements. We've got iron, we've got potassium, and then we could list out the sulfur, the oxygen, and the hydrogen, but a tip from me to you when doing these, if you have polyatomic ions that are on both sides of the equation, so like sulfur or sulfate is over here, and hydroxide is over here and over here, you can just list the polyatomic ions instead of the elements. Okay, so you can, rather than doing sulfur and oxygen, you can just do SO4 and OH. Okay, because unless you're doing a decomposition or synthesis reaction, polyatomic ions are never going to break up in a double or single replacement reaction. So we'll list them over here as well. Iron, potassium, sulfur, or sulfate, and hydroxide. Okay, so how many irons over here? We've got 2. How many potassiums? 1. How many sulfates? 3. Just remember it's outside the parentheses. How many hydroxides? 1. And then how many irons over here? 1. 2 potassiums, 1 sulfate, and 3 hydroxides. Okay, so we will do MnO again. All right, Me. Well, we've got 2 metals now. We've got iron and potassium. So if we put a 2 out front here, we'll fix our irons. And if we put a 2 out front here, we will fix our potassiums. Okay, but we're not done, because putting those 2's out front has changed the number of hydroxides in this equation, right? Over here, there are now 2 hydroxides, and over here, there are now 6 hydroxides. Okay, so let's move on to our non-metals and try to work out those sulfates and see. Oftentimes, if you kind of go through this process, things will work themselves out, but if not, you can kind of fix it at the end. So let's try to work out the sulfates now. So we've got 3 over here and 1 over here, so it makes sense to me that we would put a 3 out front of the potassium sulfate, change that from 1 to 3. But again, that means we change the potassiums, and over here, instead of 2, there are now 6 potassiums. Okay, and so in order to rebalance the potassiums, we need to change this from 2 to 6. And so this number can no longer be 2, it has to be 6. Alright, and then that changes the hydroxides, and they're no longer 2, they are 6. Okay, and now it looks like we've accounted for everything, so let's just check both sides. We've got 2 and 2, good. We've got 6 and 6 for the potassiums, good. We've got 3 and 3 for the sulfates, and 6 and 6 for the hydroxides. So we are balanced with the coefficients being 1, 6, 3, and 2. Alright, so remember that trick with the polyatomic ions. It'll save you a lot of time and confusion. Alright, then our last example, I believe. What type of reaction is this? It is combustion, right? Because you got a hydrocarbon and oxygen making carbon dioxide and water. So, as is always the case in a combustion reaction, we've got CH and O, and CH and O. So, how many carbons over here? 9. How many hydrogens? 20. And how many oxygens? 2. And then on our product side, we have 1 carbon, 2 hydrogens, and 3 oxygen. Excuse me. So, following MnO, start with the metals. There are no metals, so we're done. Then we go to the non-metals. Once again, we've only got carbon. So, we'll balance the carbon. This needs to go from a 1 to a 9. So, we put a 9 out front here. And so that fixes the carbons, but now changes the oxygens. So the oxygens go from 3 to, this is 9 times 2 plus 1, 19. Okay. And the oxygens stay the same over here. Alright. Then we, well, in the case of combustions, you can see that because this is an odd number for the oxygens and an even number, it might be best to just go with the hydrogens for here, right? Where if we change this to 20, that means we put a 10 out front of the water. So we've got 20 here, but now the oxygens have changed again to 18 plus 10, which is 28. And so we can balance this by changing it to 28, which means we need 14 over here. And that balances the equation with 9, 10, and 28 for all three. Okay, so you can see in this case the O and the H, it's not a hard and fast rule. You should really just go with whichever one is more convenient for you. So, sometimes I suppose it can be men-ho instead of men-o. Okay? So, if this has confused you or sort of overwhelmed you, just be secure in the fact that we are going to do a ton of practice with this, and by the time we get to the review and the exam next week, you're going to be a pro at this. Okay? So, as long as you know the sort of basic rules and how to kind of make these calculations and write this line down the middle and count them up, you will be fine. All right, I will see you in class.